Hello folks, and welcome to what I'm promising to be not the most boring video that I've ever made, because that's quite a high bar, but it is going to be a fairly boring video. And the content of this will be, we are going to be looking over in some rather excruciating detail the wiring connections between the ZombieVerter VCU and the currently two Toyota hybrid systems that I have here on the bench. So the GS450H and GS300H inverters and gearboxes. We'll do this in two parts. I will show you on the bench the physical setup, and then I'll jump on the computer here and I will film me showing you the various pins and where to find the pinouts and so on the Open Inverter wiki. So before we delve into this, just to clarify a few things. First of all, this will not be super detailed. If I make a super detailed video where I take every pin and describe exactly where it goes and what it does and why it needs to be there and why you shouldn't do something else, the video will be about 3 hours long. That's no problem. I'm perfectly happy to do that, but then basically nobody will watch it. At best, they'll get on the forum and ask questions, which will of course be answered in the 3-hour video. And then I'll get hacked off because I'll have already answered them, and then everyone else will get hacked off and everyone gets hacked off. So instead, we will cover the most important parts of this in a reasonable amount of detail. So hopefully everyone will get the information that they need without having to put up with too much of me. So, second thing before we jump straight into this. And this applies not just to Toyota, applies to any and all inverters and or high voltage components that you may find yourself experimenting with on the bench, in a car, etc. Far too often I see folks or I see posts like, we'll have someone running a bench test on something, be it, let's say, a motor and an inverter package. And it'll come out as something like, oh, the inverter's not working anymore. So then you'll delve into it a little bit. And, well, it was working fine and then it stopped. Then you get a little bit more detail. It was working fine and then the fuse that I had blew. So I put a new fuse in and now the inverter doesn't work anymore. Okay. At this point, I'm usually pulling out what's left of my hair. And there's, get a look in there. There's not a lot for me to grab onto, okay? So what's happened in that situation is that your fuse has done exactly what it's supposed to do. It protected the wiring from your battery or power supply to your inverter or charger or whatever else that you were experimenting with. It made sure that that wiring didn't get damaged. But it did nothing to protect the piece of equipment, which is one of the biggest misconceptions that I think is perpetrated or experienced out there in all walks of electrical systems and installations and electronics. Fuses are not designed to protect the equipment. They're designed to protect the wiring going to and from it. So, how do we avoid blowing ourselves up? Well, what we need is not a current interruption device. We need a current limiting device. So when I'm on the bench here, I usually use power supplies. So they have a presettable current limit in there. So I can set how much current I want the thing to draw. And if it tries to draw more current than that, the power supply drops the voltage down to limit the current. Now, Not everyone has all this kind of equipment available to them. Most of us are just using a battery or part of a battery or something like that. Fortunately, there is a solution for you. And guess what? It's not a fuse. This is it. What you're looking at here, I see the writing on it. Might even be able to tell you. Ah, here we are. It is a 2,500 watt, 230 volt electric cooker element. These are ubiquitous all over the world. You know, you can find them in a junkyard, a recycling center, appliance repair shops, everywhere. I think the 10 euros, 15 at the absolute outside, all the way down to free. What this is a PTC resistor with about 10 ohms of resistance. What we do is we connect it just like we connect a fuse. Put a wire in here and a wire out here. We put it in series with whatever piece of equipment that we're playing with. If the piece of equipment malfunctions and tries to draw too much current, guess what this is going to do? Well, it's going to do what it was designed to do. Originally, it's going to start getting hot. And when it starts getting hot, its resistance is going to increase. And so the current flowing through it is going to decrease. So congratulations, you've got a current limited power supply, and you can choose by the wattage or how many of these that you connect in series or in parallel to limit your current and your potential for having problems and destroying destroying expensive material. So I'll wear it on my head like this, okay? Sit it around like that. So hopefully the fact that I have an electric cooker element on my head will serve as some kind of a memory hook for folks when they are experimenting with high voltage components, again, inverters, motors, chargers, DC-DC converters, heaters, air conditioning pumps, whatever. If you're not sure what you're doing, you're not sure if you've wired it up properly, or maybe there's a pinout you're not certain about, all that kind of thing, and you're just thinking, will I just throw the wire on the battery? Sure, do. But don't put this on your head. Put it in series with that wire that you're about to connect to the battery. Now, with that said, I'll take this thing off my head and we're going to go hit the bench here and we will show you what we've got going on. Alrighty, so let's start from this side. So on our left, which is currently connected up to our VCU, is our Lexus GS450H gearbox, and on our right is our Lexus GS300H gearbox. So we'll start off and we will show you the 450H. So first of all, we'll start here on this side. We'll give you a little bit of a tour, a little bit of a panoramic tour here. So MG1 resolver connector, MG2 resolver connector. These guys also have the MG1 temperature sensor wires, the MG2 temperature sensor wires in there. For our first coolant hose, towards the tail shaft, we have our shift position and solenoids connector. On the other side, if we can thread you in here, we have our oil pump. Say hello to oil pump. There's our oil pump motor. We have our shift position sensor wiring connector. Oil pump wiring comes up here. No, let go. So the joys of having so many cables running around the place. Here on the front, a very crude way of locking the gearbox input shaft, just with a vice grips and a cable tie. just for testing purposes. Oil pump cable, so coming around from the side, goes to our oil pump controller. Our oil pump controller here has the two wiring connectors from the oil pump, so power and resolver. And it connects to a car battery here, because this thing does draw about 25 amps. I don't have a DC power supply that's capable of running that. So we have our blue wire, which connects to battery positive. We have a ground that connects to casing of the controller. A brown wire and a black wire. The black wire is our PWM signal, which connects all the way back over there to our VCU, which we will show you in a second. Wiring here. So these two white wires are our MG1, and the red one is our MG2 resolver signals. So these signals come from our MG1 resolver connector, MG2 resolver connector, and connect all the way back up here. There's our two wires again, and they connect to our inverter. This guy is our GS450H inverter. This is the data and low voltage power connector here. Our resolver wires connect into this guy. So, other wiring connections that we have here. These guys, these two, and I won't go into too much details on these because these are still experimental. But one of these guys here, this one, this yellow one, connects to our shift solenoids and position sensors and goes all the way back along over here, all the way back along over here, and goes to our VCU. Finally, the second of these black wires, this black wire, has our MG1 and MG2 temperature sensors, which are in these two plugs here again. And that goes all the way back along here, all the way back along here, all the way back along here, and goes into our VCU. And we will show you on the computer which pins, etc. to use. So the 450H has quite a bit of wiring going to its gearbox, but not too hard to do if you're able to get some of the original wiring. I was kind of semi-lucky, semi-unlucky in that, yes, I got the harness, but it had to be cut in order for me to get it out of the car. So I've had to, join on some wires here to bring the signals where I need them to be. Now, here is our inverter. Obviously, we have our two three-phase cables, so our MG2 and MG1. Here we have a bundle of 4 grey wires, and these are our data wires, where we connect data going both to and from the inverter all the way back over here, and those very same wires connect to our VCU. Again, we will show you on the pinouts where they connect to. There's a bundle here. So for example, this bundle here is the 4 data wires for our GS450H, and these are 4 data wires for our GS300H. We obviously need a 12 volt ground, which is what this brown wire here and black wire here just go to 12 volt ground. The red wire, 12 volt positive, comes over here. Next to this relay, which basically switches on and off the 12 volt power to the inverter, and that's controlled by our VCU. So now we have gearbox connected to VCU, connected to inverter, and we have data going to and from inverter and VCU. So what's the next thing we need? Well, the next thing we need to do is to connect some high voltage to our inverter. Sadly, this is another area where I've seen folks making a mistake. In the normal operation in the Lexus, the high voltage battery connects here onto these terminals here, and there's a kind of an outlet here to connect the air conditioning compressor. Now if we come along and we connect our high voltage battery to these points here, everything will work fine here on the bench. We'll have no problems. Everything will appear to work absolutely fine. We can then go ahead, put this in a car. We can do our in-car tests. We can spin the wheels of the car with the weight of the car off the ground. This will all work fine. We can then put the car on its wheels and drive around the yard, drive up and down the lane, wherever we may be, and this will work fine. And we will be thinking everything's peachy. Then we'll say, right, it's time to go for a proper test drive. And we'll get out on a motorway or a faster road and we'll put the foot down. And the inverter will then explode. We'll have to get our car hauled back home and basically try to figure out what went wrong. And yeah, if you connect your high voltage here, you are running it through the boost IGBT and the boost inductor, which are in here. Those components are designed in the original application to run a maximum of about 100 amps and probably not for very long. They are liquid cooled, so you can get, you can stress them, and they are Toyota, so it can be hard to kill them, but they will die. And I have at least 2 people that I know of that have blown up these inverters by doing that. Now, pretty much in every video that I've made or tried to explain is that we don't want to do that when we're using this for an electric vehicle application. Instead, you'll notice here I have these 2 brass pillars. So let's get right in here and show you what we have. In the normal sense, there'll be a black plastic cover over this. So you won't see that, you'll just see a black plastic cover in there. You want to take that cover off, and you'll have to be careful with it. Just prise it gently because it's got some of the famous Toyota glue. And when you get in there, you're going to find that there's 2 little, I put Nord locks on these so I'm making life hard for myself. You're going to find that there's 2 small bolts in here. So you have a little M6 bolt with a 10mm head on it. You want to take these 2 bolts out. You want to get your 2 pillars. Now, I did at one point sell these. I have to get more of them made so I can sell them again. But they're not hard to make. And I think I've published the dimensions, at least of these ones. And some folks, far better at this kind of stuff than me, have made nice 3D printed casing that kind of bolts on here and covers all this up so you don't put your fingers in here. But Basically, we're connecting our high voltage positive here to this pillar and our high voltage negative here to this pillar. And in doing so, we are bypassing the boost inductor and the boost IGBT. We can now pump current in and out of those terminals without fear of having any problems with our inverter. The GS300H inverter is very, very similar. Normally, we would connect our high voltage battery in the normal Lexus hybrid vehicle to these terminals here. If we do that, we go driving fast, this will explode. Instead, got to pop off another little plastic cover, take out the two 6mm bolts and put our two brass posts in there. Now let's have a quick look at our VCU side. So this is our ZombieVerter VCU. You can ignore this little wiring mess here. I'm in the process at the time of making this video of coming up with an alternative to these stupid Olimex Wi-Fi modules. So I'm doing some testing. This is our VCU. This power supply here simulates our high voltage. We get about 50-60 volts out of it, about 5 amps. This power supply here simulates a 12 volt battery, just supplies about 13-14 volts to our VCU and our inverter. We've got a throttle pedal to apply throttle. Got some wires here just randomly lying around where I apply forward and reverse signals. Got an ignition switch here, so on off for ignition, and a start button or key to start position there. All of this, how the wiring is connected and what all of those buttons and switches and all of that works, is described in the series of videos that I did on the VCU. So again, I'm not going to get into what every single wire does here, because in doing so, we would have a 3-hour video that nobody would watch. Not that anyone's going to really watch any of these videos, but hey. Anyway. So, have our VCU, we have our either power supplies or batteries protected by a current limiting device, not a current interruption device, please. If you want to do the same for 12 volt systems, just use a tail lamp bulb. Tail lamp bulb, current limiting device. So, let's go fire it up. Okay, so 12 volt power on. And our VCU is alive. How do we know that? Got our power light on and our activity light blinking. Let's put our high voltage on, fake high voltage in this case. Turn our ignition switch on, click. And here, I'm going to press my start button. Okay, let's go ahead and turn our ignition switch on and press our start button. So, first thing that we're going to see or hear, is that our oil pump is pumping. It is a very noisy pump. They all seem to be, even when you put new bearings in them. I don't know why. This one I've set at 30% PWM. Take our throttle pedal. If you look at the output shaft here, give you a better view of that. And there we go. We're spinning. So, this is our basic setup and what we would need to have for bench testing, be it a power supply for high voltage, power supply for 12 volts, or again, we can use a battery, test with a current limiting device, battery, current limiting device. And that is our Lexus GS450 inverter, gearbox, and so on, communicating with our VCU. So let's show you the throttle pedal here. I don't know, probably not going to be able to get a very good view on this, but I'll try and get in a bit nearer for you. It's about as fast as we'll go. Hello folks, and welcome back to the test bench. Today what we're going to be looking at is the connection of our ZombieVerter VCU to the GS300H inverter and transmission. So we're going to show you, not super detailed, but just the broad overview of the connections that we need to make between the VCU here and the inverter here and the transmission here in order to make this work. Once we have that done, I will be disconnecting the GS300 from our VCU. We will be reconnecting then the GS450H inverter and transmission. And we will be going through some debug on that system, because I think there's still some bugs in there. We're going to get those out. And we will then show you that system there, the 450, running with our VCU. So, without further ado, let's go and have a very quick demo here of running the GS300 with our VCU. So VCU is powered on. I'm going to go ahead and turn on what would be our ignition switch. Flick that on. Press my start button. These little LEDs here are just representing my contactors. I'm just using those for testing. This would be our high voltage contactors. Got a relay here for supplying 12 volts power to our inverter, and a throttle pedal which we can press. So I'll just let you see the tail shaft of our gearbox, and I'll give the throttle a little squeeze. So, I'll give our throttle a little squeeze. And there we are. Just got a very crude way of holding the input shaft locked. So we're running MG1 and MG2 there, no problems at all. So, going to shut off the power, and we will go through the wiring connections here in a little more detail. So I've just gone ahead and unplugged the multi-way plug out of the VCU. There's a lot of wires going on here, but for the purposes of our needs, we really only need to focus on these four grey wires here. Now you will see that I've just color coded them just for my own ease of use here. And these are basically, there's two wires, two cores in each of these grey wires. It's a screened cable. So we have a copper screen, and this is our communication data between our VCU and our inverter. So in order for the VCU to communicate with the inverter, we need to connect these wires. And we need to connect them in the correct place and in the correct polarity. So what are they? Well, there's 4 names for the 4 wires: HTM, MTH, REQ, and CLK. Now, I'm not going to get into a long and boring description of what all of those signals do. We're not too concerned about that here. We just want to connect it. On our VCU plug, on the back, there are pin numbers etched into the plastic. And if we go to the wiki page for our VCU, we'll find a pinout where we describe what each of these pins do. So all we need to do is to match the pins here: HTM plus, HTM minus, MTH plus, MTH minus, CLK plus, CLK minus, REQ plus, and REQ minus, with their matching pins here on the inverter. And for a pinout of what pins match up to what on our inverter, you will find on the GS300H wiki page, which will be linked in the video description also. And I'm sure somebody, when they're working on this, because we've quite a few folks now that since we've got this working here on the bench, that are either starting or actually quite advanced with projects using this particular system. So I just wanted to try to unhook this plug for you. Fortunately, the Toyota plugs, this is a brand new one, so it's probably a little bit not exactly Damianized as yet. Here, of course, I'll struggle on camera. But anyway, I suppose let's not bother. These are our connections, as I say, from our data between the inverter and our VCU and vice versa. So what are all of these other cables that we have connected to the inverter? Well, let's start with the 2 simple ones. We have a white, which is a 12 volts ground, and a red, which is a 12 volts supply. Now this red supply will be switched by the VCU using this relay here. So the VCU can control the 12 volt supply to the inverter. So now we understand our 12 volt supply, our communication. But what are these 2 black wires with their cores? They are 6 core wires, and they come out of the inverter multi-way connector here, and they connect here to the side of our gearbox. The one nearest the tail shaft end is the MG2 resolver, and the one nearest the bell housing is the MG1 resolver. Now these are 8-pin connectors, of which 6 of the pins are used for the resolver, and 2 of them, which you will see here, the black and the pink wires, are the MG2 temperature sensor and the MG1 temperature sensors, and they connect back to our VCU. Pinouts for the resolvers, and as I say, relevant for the inverter, are on the wiki page also for the GS300H system. Finally, but very importantly, we have the connections for the high voltage DC to our inverter. And those of you that may be familiar with this model of inverter will know that normally on the side here there's a little black blanking plate like that. And we do not, in the OEM application, connect anything here. Instead, the battery in the Lexus is connected here. Now, we do not use the OEM connection point, but instead we come in here through this access point and connect directly in here for our high voltage. And the reason for that is that if we do not do that, if we choose to use the existing points, then we will be limited by the current carrying capability of the boost inductor in the inverter. And if we exceed the rating of that boost converter inductor for long enough, the inverter will go boom. Not good. So, this is where we connect our high voltage. This is where we connect our data. And just to clarify, our MG1 and MG2 three-phase motor connections connect in the usual places here. You'll see the two high voltage cables heading off back to our transmission. So folks, that is very kind of a high-level overview of how to connect up the GS300H system. Okay folks, so we're here on the desktop computer and we're on the Open Inverter forum. I'm going to try and show you here just how you can access the pinouts and so forth that you're going to need when wiring up particularly the GS450H and GS300H inverters to the ZombieVerter VCU. So we've shown you the physical kind of layout of the wiring there on the test bench, but what we're going to do now is kind of dig in here and show you some of the documentation. So I'm going to go to our Open Inverter forum. I'm going to click on the Wiki tab, go up to the little search box, and we'll start with the VCU. We just type VCU, press enter. So we got our ZombieVerter VCU page, and that brings us into very detailed page here on our VCU. I'd suggest that you have a good peruse through this before getting started. Anyway, the various videos where I break down all of the operation of the hardware and software are here, and they're all indexed, so that's quite useful. But anyway, we're here to get our pinout, which is going to be our first stage here. So we're going to scroll down and we get to pinout diagram. Just click on this, click on it a second time, and that brings up our pinout diagram for the VCU 56-way connector. So again, in the videos that are on the wiki page, I've gone through each and every pin on this in painstaking detail if you would like more information on them. But today we're going to concentrate on just a few pins that we need for connecting to our Lexus and indeed pretty much all Toyota inverters of their third generation. And those pins will be these ones here. So we have REQ minus, REQ plus, clock minus, clock plus, MTH minus, MTH plus, HTM minus, and HTM plus. So those are the data cables that we showed you on the bench. That's where they connect. And the relay that controls the inverter's 12-volt power supply is controlled by this pin here, which is inverter power low side switch. So next thing we want to do is again just go back to the Open Inverter forum, and go to the wiki again. And this time we will do a search for GS450H and press enter. Get our first match here, and we get our page here where we have, again, quite a lot of very good detail on the GS450H inverter, along with wiring diagrams and so forth. All the various connectors and part numbers and all that you would need. Anyway, we're going to again be just concentrating here on our pinouts. So we'll find the pinout here just on the top right hand side, and we'll just click on it the second time. Now, unfortunately, this pinout here is not as good a resolution as the one for the ZombieVerter, but still reasonably possible to make out what the pins are. And you'll see here on the connector that we've got grounds, 12 volt supply, and then if we kind of dig in here, you'll see that there's the clock plus, clock minus, HTM plus, HTM minus, and MTH plus, MTH minus, and finally, where is it hiding? Oh, where's it hiding? Rec minus and Rec plus there. So those pins there basically connect back here like for like. So we go, for example, Rec minus here will connect to a Rec minus here, and so on until we get all of these pins connected. Now, once we have all of those guys connected, both on the VCU side and on the inverter side, bearing in mind this is the GS450H inverter. So let's just very quickly, same procedure again, just wiki. I think it's under the IS300H, I think they call it here on the wiki. No, it's actually GS300. And if we look here again, you'll see that we have a pinout on this wiki page for the GS300. And we'll see again that it's got the Rec plus, Rec minus, HTM plus, HTM minus, and so on. And again, these pins, just like if we were using the GS450 here, connect like for like to these pins here. Now, a few things to note about how we connect these. Obviously, we're going to use wire, but what kind of wire? Well, ideally, as I showed you on the bench there, that grey wire that I have is a 2-core screened twisted pair wire. So we would use one wire, with the 2 cores for Rec minus and Rec plus, likewise clock minus, clock plus, and so on. Now, if you don't have access to that, some folks have used, I think, Cat6 or even Cat7 Ethernet cable. And again, that's ideal for this because it's separate twisted pairs. So that's a low cost way of doing it. So you can put one twisted pair on Rec minus and Rec plus, one twisted pair on clock minus and clock plus, and so on. Now, once we have that done, what we want to do is to have our connector header here plugged into the VCU and connected to our inverter. There's no need to have power anywhere. And what we want to do then is get a multimeter, put it on resistance, and check the resistance between your pairs here. So for example, the resistance between Rec minus and Rec plus. Now you should see in or about 60 ohms. So you should see 60 ohms, Rec minus, Rec plus, 60 ohms, clock minus, clock plus, and so on. What that's telling us is that we have a good connection then between our VCU and inverter. If, for example, we were to measure the resistance here between Rec minus and Rec plus as being 120 ohms instead, that would tell us that we had a break in the circuit either at the inverter or the VCU end. So if we can see 60 ohms between the two of each pair, that's a very good little simple diagnostic that we can do to make sure that our wiring is, as much as we can tell, intact. So that's how we connect the data between our VCU. So these are our VCU Toyota synchronous serial data lines that we showed you on the bench. This is where they connect to the VCU. This is where they connect to the inverter, again, just like for like, and so on here with the GS300. So the only other thing then that we need to supply to our inverter from the, I guess, the signal cable point of view here is 12 volt ground and a switched 12 volt supply, and that is switched from a relay that we connect to the inverter power low side switch pin here. And I've described how that works in some of the other videos there that are linked on the wiki page, so I won't rehash over that again. Now, the next phase of the operation, once we've our VCU connected to our inverter, comes from connecting the inverter resolver pins to the resolver connections on the actual gearbox. So let's see, because I haven't actually looked at this myself, but let's just back up into our wiki page here. I'm just going to have a quick look here and see basically what do we have here. Do we have the resolver wiring? We actually, am I looking at it here correctly? Yeah, we actually do, yeah. Here we go. So this diagram here, and I have to say I do like these Toyota wiring diagrams. They just, the color coding on them just makes them so very readable compared to some other ones, particularly Tesla wiring diagrams are truly horrible in my opinion. So here we're going to see, this is on the GS450H. We're going to see here that there's a connection. I think it's called E81 or E61 here. And it says motor generator number 1 front. And this one here I think is E82, motor generator number 2 front. And we have these 1, 2, 3, 4, 5, 6. So the yellow, green, red, white, blue, and black are our resolver connections that we need to connect from the resolver connector on our gearbox to our inverter. And as we showed you on the gearbox, those are 8-pin connectors, and there are part numbers for those connectors there on the wiki page. So you might say, hang on a second. So there's 6 resolver wires that we need to connect from each of the 2. So one for MG1, one for MG2. We have to connect back to the inverter. Okay, so these guys, these 6 wires here and 6 wires here have to connect to the inverter. Okay, they do not connect here to the VCU, but they connect to the inverter. And you'll see here on the GS300 one that there's, for example, let's take 2 pins here. There's GRFG and GRF. So what that actually stands for in Toyota parlance is generator exciter and generator exciter ground. And if we go back here, we should see that there's maybe GRF, here it is, and GRFG. So in this case, GRF is this blue wire. So it connects from the GRF pin on the gearbox to the GRF pin on the inverter. And it's again like for like. Again, what kind of wire would we use for this? And that is important to use a twisted pair screened cable. So again, Cat6, Cat7, Ethernet cable, I believe folks have used to good effect on this. And we would want the pairs to be twisted. So for example, GRF, we would want twisted with GRFG. Let's just run it. So let's say here on our GS300, we'd have GRFG twisted with GRF, GSNG twisted with GSN, GCSG with GCS, and so forth. So then ideally we would have all of those wires then screened, and we would pick one end and tie that screen to ground. Do not please connect the screen to ground at both sides. You will make me unhappy. And if I'm unhappy, you're unhappy. Now, lastly, on our two connectors here on the gearbox, you will observe that they're in fact 8 pins, but we're only using 6 for the resolver. The other 2 are our temperature sensors. So for example here we have GMTG and GMT, the red and the blue wires. Over here, I think it's MMTG and MMT. So this is this gray and green wire, or MG2 temperature sensors. The red and the blue here are MG1 temperature sensors, and these guys do connect back to the VCU, and they connect here. So for example, we would have MG1 temp minus and MG1 temp plus. So we would go to our diagram here, and we would connect GMTG, so the red wire, to MG1 temp minus. We would then connect GMT, so this blue wire, to MG1 temp plus. And likewise, over here, we've our MMTG and our MMT. This is our MG2, and we would connect those to our VCU MG2 temp minus, MG2 temp plus. And what the VCU will do then is it will interpret the resistance of those sensors and display that on the web interface, and so you can set derating and so forth if required. Basically what happens is, because there's 2 sensors but only one option for display on the web interface, it will basically pick the hottest of the 2 motors and display that temperature. So folks, that is how you get your pinouts and your wiring diagrams, and how you go ahead and connect up the VCU to the inverter to the gearbox resolvers. Now, obviously, the inverter 3-phase connections need to be connected to the motors. I'm not going to go through that. That's a little bit basic, so I won't go into that level of detail. I suspect I've gone into way too much detail already. Now, so what's next? Well, with the GS300H, that's it. If you wanted to, you could wire up the shift position sensor. I believe someone over on the forum has done a pinout for that already. Let me have a quick look here. I saw someone had made a Pinout for that. Go to L210 gearbox here. Oh, some administrative things for me to do. I'll deal with those later. I think someone did a pinout. Did they? Yes, they did. There we go. So someone's done pinout for the shift position sensor here. So if you wanted to use that, you could wire that up. But that would be all that you would need to do for the 300H. The 450H, there's a bit more wiring, unfortunately, because the 450H has an external oil pump. And that is our next job that we need to connect up. So if we come in here to our wiki page again, which is very, very well done, I'd like to thank the people that have contributed to this, we click oil pump. So the oil pump, as we showed you on the bench, is bolted on the side of the gearbox and has a separate controller. We have a wiring diagram here. Let's click on this and click on it again. And we have a wiring diagram here for the controller. So this is our pump controller here. And this blue wire, as we again showed you on the bench, that is our battery positive. And in this case, we have a relay that switches the power to this. We've obviously got a ground, that 12 volt ground, that connects to the casing of our controller, and that provides it with 12 volts power. Now the controller then obviously connects to the pump with its own wiring harness. We've got two signal wires here that we need to, well, one really, that we need to concern ourselves with. And this is this black wire here, SIG pin 6, whatever it is here. And that wire is our PWM control from our VCU to the pump controller. And that, we want to come over here to our VCU pinout, because we have to connect that here. And we would connect that to the oil pump PWM pin here. So that black wire from the pump controller connects here to oil pump PWM output on our VCU. So sorry again. So black wire here, pin 6, we just connect. So it's one signal wire from our our oil pump controller, that we connect to our VCU. The brown wire is a feedback signal that basically tells us what speed the pump is currently at the minute. That's not implemented anywhere. I guess you could use that in your own control system if you so wished. I don't in mine. Now, what about the oil pump relay, I hear you say? Well, again, how I've done them is, again, as per this wiring diagram here, just use a relay with a low side switch on the coil and just connect that back to our inverter power low side switch pin. So basically this pin is switching two relays. It's switching on and off the 12 volt power to the inverter and the oil pump, oh boy, the oil pump controller. So we now have the ability to spin the motors in our 450 gearbox and have our oil pump running at the same time. So what else could there be, I hear you say? Well, the 450 is the gearbox that likes to keep on giving. So there are indeed more connections that we might like to make. Now, before I jump into those connections, what I would like to point out is that you can opt at this point not to connect up anything else, and it will work just fine. You'll have your motor spinning, your motor temperature sensing, and your oil pressure working away happy as a clam. The only thing that you won't have is the ability to shift into what they call low gear in the GS450H gearbox. So Let's back up here, back to our wiki page one more time. And let's see if that is covered here. I may not be covered on the, may not be covered here in the wiki as yet, because I've only really started working on that part of the VCU firmware in recent weeks or days, even the time of making this video. But if we go back to our, here we are. It is, we have a bit of data on it. So we have a wiring diagram here, or that's the shift position sensor, sorry. That's available to you as well if you want to use the built-in shift position sensor on the gearbox. Apologies now for this, but I don't think anyone has quite given us a wiring diagram. No, on the wiki they haven't. So I think at the time of making this video, I have basic gear shifting working on our gearbox. But what I'm probably going to do is not cover the wiring of that to the VCU in too much detail, because it's still experimental. So I don't necessarily want to have people messing about too much with this. Now, I don't have a diagram here on the gearbox side, but I will see if I can dig them out and get folks to put them on the wiki page here. But if we look on the VCU pinout, we're going to see these connections here, or these pins here. So trans SP, trans SL2 minus, trans SL1 minus, then there's trans PB3, PB2 and PB1. Now these are the pins that the VCU uses to control the shift solenoids inside the gearbox, and to also sense the position feedbacks of the clutch packs and the there's a minimum pressure switch in there. I think it's can't remember exactly which. I think it's PB3. So when you've got minimum required pump pressure in there, PB3 closes. Now, as I said, I'm not going to go into details of how to wire these up yet. I'll do another little video that'll be just solely dedicated to these when we have data up here on the wiki page that I can reference back to, and it'll make more sense to folks. So for now, if you are making up a wiring harness for the VCU, for example, by all means put some wires on these pins and just leave them tied up out of the way. So I'll stop there. Probably already got people into their second sleep of the night, and we will see you in the next semi-exciting part of this semi-exciting video. So folks, there you have it. A reasonably detailed look at our VCU and how we connect it to our GS450H, GS350H, Toyota Lexus hybrid drivetrains. Coming up, we will have more Toyota hybrid systems for you. I've recently taken delivery of a P610 trans axle. So we will be examining that with a view to getting it running with our VCU. Also, we've some projects coming down the line to you, which will be using both our 450 and 350 and VCU in them. So we'll actually have running cars with these two systems in them. You know, not anytime soon, but definitely within the next 6 to 12 months, I'd like to think. So, thank you very much for taking the time to watch. As always, don't forget to dislike, do not share, do not subscribe to this stupid channel, please. If you are subscribed, unsubscribe. Do check the links in the description for GitHub, open Inverter forum, things like that. But don't support me on Patreon or PayPal or that, because then I'll just do more of this kind of thing. So until next time, happy current limiting.